quadratic functions in standard form. Last time we did vertex, today we're going to do the beloved standard form, just like our beloved Super Kelly down here. Alright, so standard form is y equals ax squared plus bx plus c. Again, a, b, and c are numbers. They can be anything, but a cannot be 0, because if it's 0, that's gone, the square term's gone, and then we just have bx plus c, and that's a linear, that's not a quadratic. Alright, quadratics in standard form, exactly the same. We have parabolas, all that same stuff. Let's see what else we have. Properties of quadratics. Let's take a look. If a is greater than 0, remember last time a was greater than 0, it meant it opened up, and it still does. That's pretty nice because that's not going to confuse us. Otherwise, if it's a negative number, it's going to open down, right? It's going to open down. Just like in vertex form, when a was a positive or negative, it determined if it opened up or opened down. And just like that, if the absolute value is greater than 1, remember greater than 1, that means it is narrower than the parent function, y equals x squared, right? Conversely, if the absolute value of a is less than 1, 0.5 or 1/4, then it is going to be wider than the parent function. All right, great stuff, because all that is exactly the same as vertex form. All right, it makes sense that it should be the same. All right, let's see here. The y-intercept. Now, this is going to be a little bit different. The y-intercept, this is kind of like slope-intercept form. The y-intercept is c. All right, if you look up here, if we put in x is 0, then that's 0, what is left? C. That's where we'd cross on our y-axis. All right, that's going to be important. We're going to want to graph that. And it's nice because that's not in vertex form. That is not true about vertex form. So y is c. The y-intercept is c. Let's see what else is new about this. The axis of symmetry. This is real important. It's not as easy to find the vertex in standard form as it was in vertex form. Obviously, it's called vertex form. All right, so we're going to have to take negative of b over 2a. So we're going to have to take our b, our 2, and our a, plug into this formula to get our x. When we have that, we can plug it back in to find the y value, because remember, the vertex is always on our axis of symmetry. All right, so negative b over 2a. Let's take a quick look. Let's see what that actually looks like in action. All right, so I have 2x squared minus 8x plus 6. Now, x squared, it's always a, b, c. If there were no x here, this would be a and c. All right, the b always goes with the x, the a always goes with the x squared, and c is always a constant. That's 6. So let's find the axis of symmetry. X equals, let's see, negative b. What's b? Negative 8. So the negative of a negative 8 over 2 times what's a? 2. So this is going to be 8 over 4, which is 2. So x equals 2. And you remember, that's a good thing to put on our graph for so many reasons. Number 1 being, need it to pass the mastery check. Need it to reflect across the other side. All right? So now we have our x value. So for our vertex, we have x is 2. All right? Now we need to plug it in and find our y value. So y equals, let's see, wherever I see x, I'm putting 2. So 2 times 2 squared minus 8 times 2 plus 6. So that's 2 times 4 minus 16 plus 6. That's 8 minus 16 plus 6. 8 minus 16 is negative 8. Negative 8 plus 6 is negative 2. So now we know our vertex is at 2, negative 2. Right there, we should plot that point, 2, negative 2. All right, I'm going to need to find a few more points, right? So I'm going to find 1, 0, and negative 1. So negative 1, 0, and 1. Those are the ones I'm going to find. Again, now, no graphing calculator at home, not a problem. You just plug those in right there, just like you found the vertex, all right? But if you want, put in your graphing calculator. I think it's a little bit easier, all right? 2x squared minus 8x plus 6. Mr. Kelly always says it's nice to know the technology. You never know when it's just going to bail you out, all right? So let's take a look. We want to know negative 1, 0, and 1. So let's scroll up here. So negative 1 was 16, 6, and 0. So come over here. 16, 6, and 0. 16, that's not going to work. 16, 6, and 0. So 1 comma 0 is right here. 0 comma 6, 1, 2, 3, 4, 5, 6 is right here. And I'm not going to be able to graph that one, am I? Now reflect it over the other side. Right there we got 1. And here's our other one. What's special about this point? That is our y-intercept. How do I know what's on the y-axis? Number 1. Number 2, look at C, 6. Better label that, 0, 6. All right? And let's draw our parabola, nice and rounded, like Mr. B. Oh, that is ugly. That is perhaps the worst parabola drawn ever. All right? And since I'm confident you can do better without me having to do it again, why don't you go ahead and do a better one on your paper? Okay? Now the big question, does the rule of 135 still work? It sure does. All right? Again, the first thing you have to do is find your vertex. So I'm going to use my formula, x equals negative b over 2a. That negative can go in either. I usually just put it on top. So b, we have a, b, and c. b is 4, so negative 4 over 2 times. If there's not a number, it's always a 1. Negative 4 divided by 2 is negative 2. So x is negative 2. I'm going to draw that axis symmetry over here. Right there. All right, let's find my y value. So wherever I see x, I have to plug that in. Negative 2 squared plus 4 times negative 2 minus 3. So we have 4 minus 8 minus 3. 4 minus 8 is negative 4, minus 3 is negative 7. So our vertex is at negative 2, negative 7. Negative 2, negative 7. 1, 2, 3, 4, 5, 6, 7, right there. All right, what's another point we know right now off the bat? That's right, the y-intercept, negative 3. 1, 2, 3. So I can put that here. Now, some of you may not want to do it that way. That's fine. I just wanted to show you could do that. So our 1 through 5, 1 over, 1 up. 1 over 3 up, 1, 2, 3. 1 over 5 up, 1, 2, 3, 4, 5. And reflect the points. 1, 2, 3, 1, 2, 3. 1, 2, 1, 2, and 1. And then make a nice rounded, I'm going to have to prove myself over. That last one was so bad. Rounded parabola. All right, we might want to label our vertex negative 2, negative 7. All right, let's try the next one. Do this one in red. So, x equals negative b, again, a, b, c. So negative 2 over 2 times 1 half. 2 times 1 half is 1. Negative 2 divided by 1 is negative 2. Plug it in. Find our y value. 1 half times negative 2 squared plus 2 times negative 2 minus 3. Negative 2 squared is 4. Half of 4 is 2. 2 times negative 2 is negative 4 minus 3. So we have 2 minus 4 is negative 2. Negative 2 minus 3 is negative 5. So our vertex is negative 2, negative 5. All right. Oh, look, we have the same axis of symmetry, don't we? So negative 2, 1, 2, 3, 4, 5. right there. All right, so that's -2, -5. So let's see what we got. 1/2. That means I'm going to go over 1/2 times 1 is 1/2. 1/2 times 3 is 3/2, or 1 1/2, right? And then 1/2, or 5 times 1/2 is 5/2, also known as 2 1/2. So let's check it out. So we go over 1, up 1/2. Over 1, up 1/2, and a 1. Oh, we even have the same intercept. Over 1, up 2 and 1/2. This is kind of a good one to do because you can totally see how this is a wider parabola, because the axis of symmetry is the same, and you can see it's getting wider right there. All right. Tell whether the quadratic has a minimum or maximum value, then find out that value. So let's take a look. It's a positive, so it opens up. So that means we have a minimum value. So I'm going to write my answer. Minimum value of, and we need to find the y. Now it's not as easy to find our y, our vertex. We have to find the x first. So x equals -6 over 2 times 3/2. Those cancel out, so I got -6 over 3, which is -2. That has come up like 3 times in a row. Plug that in. 3/2 times -2 squared plus 6 times -2 plus 4. All right, here we go. -2 squared is 4. 3/2 times 4 minus 12 plus 4. That goes in twice, so 6. -12 plus 4 is -8, -2. So we have a minimum value of -2. All right? All right, something new. Now we're going to go from vertex form, is which we have right now, to standard form. To do that, we're going to have to do some algebra 1. All right? Because right here we have to multiply. This is x plus 2 twice. All right, and then we have a subtract 4. So now that's just double distribution. So I'm going to distribute x. X times x is x squared. X times 2 is 2x. Now I distribute my 2. 2 times x is 2x. 2 times 2 is 4. And don't forget this minus 4 at the end. Combine like terms. X squared, I have 2x's and 2x's, that's 4x's. 4 minus 4 is 0. So, in standard form, the same thing there is going to be x squared plus 4x. All right? Let's try a little bit harder one. So, y equals -3 times this. I'd say that because when I'm done multiplying these two, I'm going to have to multiply it by -3. But am I going to multiply the -3 by 4? No. See, it's not multiplying the 4. So -3 times, distribute the x. X times x is x squared. X times -1 is -1x. -1 times x is -x. And -1 times 1 is a positive 1. I'm going to keep the grouping there because I need to multiply by -3 now. -3 times x squared, so -3x squared. Negative times of a negative is a positive 3x. I could have combined here, huh? Plus 3x, and then minus 3 plus 4. Now, like I said, you could have combined these first, then distributed. That's fine. So -3x squared plus 6x plus 1. So vertex form to standard form. All right. Super Kelly. Super Kelly's a newbie. He's able to leap tall buildings in a single bound. All right. Figured out the equation of his jump. How high did he jump? So we know that's negative, it opens down, so we need to find our x. So it's negative b, negative 200 over 2 times negative 1. Negative 200 over negative 2 is 100. So that's my x. I need to find my y value because we know it's going to be a maximum. So plug that in. So negative 100 squared plus 200 times 100 minus 8,500. All right. Do all that math out and you should get, he was able to leap 1,500 feet. Way to go, Super Kelly. So pause the video and try this one. All right. So let's see, I have A, B, and C. So I'm going to find my x. Negative B. So negative 8 is 8. 2 times A, 2 times negative 2 is negative 4. So my x is negative 2. Can you see I have a pattern? So x is negative 2. Now I need to find my y. So negative 2 times negative 2 squared minus 8 times negative 2 plus 2. Negative 2 squared is 4. 4 times negative 2, that's negative 8 plus 16 plus 2. 16 plus 2 is 18 minus 8 is 10. So negative 2, 10 right there. All right, and it's down 2, so it's over 1, down 2. Over 1, down 6. 1, 2, 3, 4, 5, 6, which matches up nicely with our intercept. Over 1, down 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Just made it. Reflected across the axis of symmetry. 2 over. And then try desperately to draw a nice round quadratic. That's awful. All right. Tell whether the quadratic has a maximum or minimum. Excuse me. Well, we know since it's negative, it opens down, so this is going to be a maximum value. All right, let's find what it is. So we can find our x is negative 7 over 2, or excuse me, negative and negative is a positive 7 over 2 times negative 1/4. That's 7 over negative 1/2. 7 divided by negative 1/2 is negative 14. Plug it in. Negative 14 squared is 196. 7 times 14 is 98. 1/4 of 196 is 49, and it's a negative. So 51. So we have a maximum value of 51. All right. So I'm going to leave you with my, favorite group of guys arguing all about Superman. Till next time, see you on the flip side.
Honey, wait.
Yeah.
If you don't have any other plans, do you want to join us for Thai food and a Superman movie marathon?
A marathon? Wow, how many Superman movies are there?
You're kidding, right?
You know, I do like the one where Lois Lane falls from the helicopter and Superman swooshes down and catches her. Which one was that?
One.
You realize that scene was rife with scientific inaccuracy.
Yes, I know, men can't fly.
No, let's assume that they can. Lois Lane is falling, accelerating at an initial rate of 32 feet per second. Superman swoops down to save her by reaching out 2 arms of steel. Miss Lane, who is now traveling at approximately 120 miles an hour, hits them and is immediately sliced into 3 equal pieces.
Unless Superman matches her speed and decelerates.
In what space, sir? In what space? She's 2 feet above the ground. Frankly, if he really loved her, he'd let her hit the pavement. It'd be a more merciful death.
Excuse me, your entire argument is predicated on the assumption that Superman's flight is a feat of strength.
Are you listening to yourself? It is well established that Superman's flight is a feat of strength. It is an extension of his ability to leap tall buildings, an ability he derives from exposure to Earth's yellow sun.
And you don't have a problem with that? How does he fly at night?
A combination of the moon's solar reflection and the energy storage capacity of Kryptonian skin cells.
I'm just gonna go wash up.
I have 2,600 comic books in there. I challenge you to find a single reference to Kryptonian skin cells.
Challenge accepted. We're locked out.
Also, the pretty girl left.